Surface and usual surface, yes? Okay. The surface of the ball is hypersurface in R3. But if you have some thread, some line in the surface, in this three-dimensional space, it's surface. It can be considered as surface because it has one dimension and the space is three-dimensional. So difference in dimensions is 2. If the dimension of the surface is dimension of the space -1, it's hypersurface. Hyperplane, for example, it's a plane which has n-1 dimension in Euclidean n-dimensional space. So a hypersurface. Hypersurface has dimension 2 in three-dimensional space, dimension 5 in six-dimensional space, and so it's missing only one dimension to the space. The surface is when it's missing more dimensions.
Other questions, please? Maybe I can ask about last slide. How to make operator invertible? Yeah, you say it can change space or change the operator. What is preferable way here? It doesn't matter.
We don't know actually.
In some questions,
Both approaches are good, but I cannot tell. Maybe for one purpose will be one better, for another purpose will be another one. We will work it out completely. We are not completely through with our problems, and we can talk about this later when we will know more about it. Which one is more useful?
Yeah, in this case, because in numerical analysis it's usually better to change operator and keep the space.
Same space. Well, but here you detach only one dimension from the space. I mean constants, which are anyway useless.
But sometimes it can change this space.
We are trying also to mostly, up to now, in my publications I was using the first approach where I don't change the space and change only the operator. I take the subtract only the function, multiplication by function. I was always using this trick.
Thank you. Any other?
Yeah, you have questions? Yeah, please.
Can we say, for example, that derivative live in the surface?
Leave surface? Leaves surface, yes? Or what? Okay. There are two aspects of this question. First of all, derivative leaves surface. I understand in the following way. When the derivative you take along this such vector field which comes out of the surface is not tangential, then the derivative leaves the surface. And you cannot apply. When you cannot take increment of the argument of the function along this vector because it's coming out of the surface. It leaves surface. But derivative leaves on the surface. It means that if it is tangential derivative, then it leaves on the surface and you can apply it to the functions which live on the surface, which are defined only on the surface. You see, take very simple example. You have car, and you want to define derivative of the function which is defined only on the car. Only on the car. How you can define? You should take increment along the curve only. So if the derivative is not tangential, you cannot take this. If derivative, you want to take coordinate derivative in the direction of x1, you cannot take it because you cannot consider function difference of the arguments of the function along this, because it's coming out of the surface. You have no value of, you have value of phi x, but you have no value of phi x plus h. In this case, you have not this value. But if it is tangential, then you can define such increment and define the tangential derivative.
It's okay.
Thank you for your interest and yes.
So maybe other questions.
If you have some further questions, we can speak after the seminar.
Professor Duduchava will stay here for
1 week more.
And you can always This is room M1.32.
132. 1.32.
Okay, if no more questions, let's send Professor Duduchava.
Thank you for your attention. Thank you.
Okay, thank you everybody for attending. See you next time.